Melanie once again, grade 11th. This is another example on stoichiometry. We look at the balanced equation. They say that you have hydrogen, which is diatomic, reacting with diatomic oxygen to give you water molecule. So you have two hydrogen molecules reacting with one diatomic oxygen to give you two water molecules. Let's see. So you have H2 plus O2 giving you H2O, that is 2 there, and that is 2 there. So the ratio will be 2, 1, 2. They say, how many moles, you want the number of moles of H2O, are formed when 5 moles of O2 react with excess H2. Remember for the grade 11s that I said if one of the reactants it is in excess, you want to try and play away from its number of moles if you want to compare the mole ratios, because you know that for an excess or for the reactant which is going to be in excess, what it means is some of that reactant will be used in the chemical reaction and some will remain. So not all of that reactant is going to be used. So you want to try and stay away from it. For example, if they had given you the number of moles of oxygen and the number of moles of um, hydrogen, it doesn't mean or you were just going to decide which one on your own. You automatically would go for the number of moles of oxygen. Why? Because hydrogen is in excess, and if it is in excess, then it means that um, not all of the hydrogen is going to be used up by the end of the chemical reaction. So I hope that you remember this for other questions, even though you are given the number of moles or the mass of that particular reactant which is in excess. So they say that how many moles of H2O are formed when you have 5 moles, you have the number of moles of O2, which is 5 mole. Now we look at the mole ratios. Bless me, sorry. You have O2 is to H2O. The ratio you have 1 is to 2, so that is 1 is to 2. And if they say that you have 5 moles of O2, then it means that you're going to have 2 over 1 multiplied by 5 moles in order to get the number of moles of water. We went through this over and over again. I believe that you know how we got to that. So that's going to be 10 moles. So the number of moles of H2O will be equals to 10 moles. B says, what mass of H2O is formed when 5 moles of O2 reacts with excess? So you've calculated the number of moles. Now they want the mass of O2. B mass of H2O equals 2. The number of moles from the formula, you know the formula by now. There's no need to go through it again. Number of moles multiplied by the molar mass. And number of moles we say is 10 multiplied by the molar mass. You have 2 hydrogens, that is 2 times the molar mass of hydrogen is 1, plus you have 1 oxygen, and that is 16. There. Let me just do that properly. Right there. And that means it's 10 multiplied by 18, and that is 180 grams. And so you have the mass of water, which is 180 grams. Now, C says, what mass of H2 is needed to react with 64 grams of O2? Now, they give you the mass of O2. And they want to know what mass is needed. Remember, if you're looking at the mass that is needed, you look at the mole ratios or the coefficients, right? What mass of H2 is needed to react with 64 grams of 64 grams of O2? And you want the mass of H2. Oh, okay. So because you have the mass of oxygen, you are able to calculate the number of moles of oxygen, which is going to be 64 over 16. Let us look at that very quickly. 64 divided by 16 gives you 4, equals 4 moles, right? This is the number of moles of oxygen if you have 64 grams of oxygen. And then the next thing you're going to do, you then compare the number of moles of oxygen to the number of moles. Remember, you want the mass of hydrogen, right? So you're going to compare the mole ratios of hydrogen and that of oxygen to get the number of moles of hydrogen and therefore get the mass of hydrogen. So that is going to be H2 is to O2, the ratio is 2 is to 1. And if you have 4 moles of oxygen, then times 2, that's going to be 8 moles of hydrogen. Therefore, we say that the number of moles of H2 equals to 8 mole. Now you have, I'm going to continue this side. Now you have the number of moles of hydrogen. You are then going to calculate the mass of H2, which is needed. And that's going to be number of moles multiplied by the molar mass. Number of moles is 8 multiplied by the molar mass is 2 times 1, which is 2. And 8 times 2 is 16 grams. So for 64 grams of oxygen, you need 16 grams of hydrogen, right? So 64 grams of oxygen will react with 16 grams of hydrogen to form water molecules. And the last one, it says, what volume of O2? You need volume of O2 at standard temperature and pressure. Remember, at standard temperature and pressure, the molar volume equals to 22.4 cubic decimeters. What volume of oxygen at standard temperature is required to react with 11.2 cubic decimeters of hydrogen? Right. So, because they gave you the number of, the volume of hydrogen, and you know the molar volume, what you can do is calculate the number of moles of hydrogen, and after that, you are then going to find the volume of oxygen using the number of moles that you would have compared using the coefficients. Let us look at that. We know the volume of H2, which is 11.2 cubic decimeters. And because we know the volume, number of moles of H2 will be equal to V over Vm, which is equal to 11.2 over 22.4, which is, I believe it's half. 11.2 divided by 22.4. Let me just verify. Yes, that is half. That is equal to 0.5 mole. 0.5 moles. You know the number of moles of hydrogen now, and according to the ratio, H2 is to O2 is 2 is to 1. And if 2 is to 1, if you have 0.5, then half of 0.5 will be 0.25 mole. So the number of moles of oxygen will be 0.25. And now you want to calculate the volume. Volume of O2 at standard temperature and pressure will be the number of moles multiplied by the molar volume. We know the equation. We've gone through that over and over again. No need to go through it again. So volume will be equal to number of moles of oxygen we say is 0.25 multiplied by 22.4, which is the molar volume. You know, at standard temperature, Vm is constant. It is always 22.4. And that's going to be 0.25 times 22.4. It gives us 5.6. Remember, because it's volume, it has to be in cubic decimeter. And that answers the last question. I hope it was very helpful and I hope that you understand. So we'll keep on checking more examples and goodbye.